Good morning, students. And so there are concerns about yesterday's assignment. And so we have stepped a little too ahead of ourselves, and so we're going to step back. Now, in order to do the assignment from yesterday, there are steps that I highly recommend following. 1. Read the question carefully to determine the genotype of the parents. Now, I noticed that there are students who wrote random answers, which shows you did not read the question. So, I highly recommend reading the question. We did not provide a Punnett square. Some of you were asking for one. Now, you can add a table into the Google Doc, or you can do it on pen and paper. And so for step 2, after you determine the genotype of the parents, I suggest making a Punnett square and fill in the Punnett square in order to determine the genotype of the offspring. After you finish your Punnett square, then it's simple. Interpret your data. For the genotype percentages, how many are a certain genotype? How many are homozygous dominant? How many are heterozygous? How many are homozygous recessive? Phenotype. Phenotype percentage is to show Miss Butler, Mr. McKay, and I how many understand the vocabulary word dominant versus recessive. And so these are the 3 steps that I highly recommend that you follow. Now, before we revisit the assignment, there are vocabulary words that you must understand in order to succeed in your assignment. The word homozygous, the word homo means same. That means that both alleles are the same. And so in the example I provided, 2 capital T's, that is homozygous dominant. So if they're both capital, they're dominant. 2 lowercase, that is homozygous recessive. Heterozygous. Hetero. The word hetero means different. Both alleles are different. And so this is the hybrid that I was talking about in previous lessons. The genotype is a mix. There's one dominant and one recessive. That is homozygous and heterozygous definitions. Now, dominant, it is a trait that will always be expressed. And so for homozygous and heterozygous, this is a heterozygous and this is a homozygous. These 2 have dominant trait. And so even if you have one allele, one, in the case of the hybrid, the dominant trait will always be expressed. Recessive, that is the shy trait. It will only be expressed when there are no dominant trait. And so the only time that a recessive trait is expressed is when it's homozygous recessive. And when it's homozygous recessive, that means both alleles are lowercased. Genotype. The genotype is just the code. 2 capital T's, 1 capital T, 1 lowercase t. The hybrid. That is just the genotype for a hybrid is 1 capital letter and 1 lowercase letter. Homozygous recessive, both are lowercase. Genotype, the code. Easy peasy. Phenotype. Phenotype is actually the expression of the code. And so in my example, 2 T's, the homozygous dominant is tall because the trait is dominant. The heterozygous, the hybrid, it has one dominant trait. So the phenotype has to be tall because tall is dominant. And lowercase t, it's recessive. And so what's the opposite of tall? Short. Since there is no dominant trait, both alleles are recessive, so short is expressed. And so I will model question 1 for you. And this is a step-by-step approach to the question. Step 1, read the question carefully for information. So number 1, in horses, straight manes, represented by capital M, are dominant to curly manes, represented by lowercase m. A curly maned horse is mated to a hybrid horse. And so just from reading this question, what do we know? I have highlighted the important information. Right there, we know straight manes represented by capital M, dominant. Straight mane is dominant trait, capital M. Curly mane is recessive, lowercase m. Curly mane, recessive, lowercase m. Now, the question is asking, what is the result of a mating between a curly maned horse to a hybrid horse? And so, curly maned horse mated with a hybrid horse. Step 1, finish. That is all the information we need now. Step 2, what are the genotypes of the parents? And so, we know the parent. Parent 1, curly maned horse. Parent 2, hybrid horse. And so, since we know curly maned is recessive, parent 1, both alleles has to be lowercase because it's a recessive trait. In order to express recessive traits, both alleles need to be recessive. And so, 2 little m's, that's parent 1. Hybrid, that is the giveaway. A hybrid horse. 1 capital M, 1 lowercase m. And so, right there, we know what the parents are. Curly maned horse mates. So curly maned horse mates with hybrid horse. That is step 2. Now, step 3 is where we construct our Punnett square. And so right there, I have a Punnett square right there. You can do this on paper, or you can add a table onto your Google Doc. And so I've color-coded all the alleles just so that you can see my process. So the first thing you're going to do is you're going to input the parent's allele. And so top row, that is parent 1. So right there we have 1M, second M. Parent 2 goes into the column to the left. And so first one is big M and little m. Notice the colors. I am following what I am given, what I have figured out so far. Now we're going to input the offsprings. These are the offsprings. And so now the rule of writing the genotype is that the capital, if there is a capital letter, you will put that as the first letter. And so there's a capital M. This M is distributed to the whole row. Because remember, the offspring is 50% mom and 50% dad. And so in this possibility, these two possible offsprings. 50% is that one trait from parent 2. And so, I'm going to take that M, input, input. Now, we're going to take this little m, and we're going to do the same thing. We're going to transfer it over. We're going to distribute it through the row. Now, this little m, you will distribute it down the column. You're going to take this m, distribute it, and distribute it. Same thing with this little m. And right there, you have performed a Punnett square. Now the final step is to interpret the Punnett square. And so, just for a disclaimer, there should not be 10% in your answer. There should not be 30% in your answer, because I notice roughly a third of students are claiming there are 10% and 30%. There are only 4 possible offsprings. 1 out of 4 is 25%. 2 out of 4, 50%. 3 out of 4, 75. And if all of them, 100%. Easy peasy. Now, the genotype. We are going through specific genotypes. How many percent of the offspring is homozygous dominant? You will look at the chart. Do you see any? I do not see any. So, 0%. How many are heterozygous? 1. 2. Nope. Nope. 2 out of 4. 50%. How many are homozygous recessive? No. Nope. 1. 2. 2 out of 4. 50%. Notice, 50 plus 50, that's 100%. All the offsprings are accounted for. All 4 of them are counted. So, your percentages need to add up to 100. It should not add up to 150. It should not add up to 200, because then you did the math wrong. That's all I can say. Miss Inderis will probably have a heart attack. Now, phenotype. We're talking about how many have straight manes. And so, straight mane is a dominant trait. So, even if there is one allele that is dominant, it will be expressed. So, we have 0%. Alright, so ignore that. None of them are homozygous dominant. So, but there is still the heterozygous, the hybrid. 50% of them should have straight manes. Curly mane, it is a recessive trait. So, only homozygous recessive will have curly manes. And so, 50% of them have curly manes. And right there, that is how you interpret the Punnett square. And so, for the instructions for today, I have modeled how to do question 1. So you will finish. First, you're going to do today's assessment. This is to make sure so that I can check, did you watch my video? Then, after you've done the assessment, you will return to yesterday's assignment and review question 2, 3, 4, and 5. Review, make corrections, and resubmit your work. That is all. Thank you for watching the video. Kudos to those who followed the video to the end. Good luck.